Okay, so as we're continuing talking about GCF and LCM, this is on the paper that we just handed out to you guys. It's not in your book, but you'll be able to go through these. The cool thing on this is we're getting a lot of review on some of this vocabulary. So remember, a factor is a number n that will multiply by another whole number equals some number. In other words, if I'm doing a multiplication problem, it's the numbers that I'm multiplying together. Those are the factors. A factor pair is a pair of factors, product equals a number. So if I'm looking at factor pairs, I'm going to give you a number that is the product of those two, and ask you what two numbers go together to make it. Those are the pairs. Your multiples. Multiples are from the number, everything going out as I multiply it by whole numbers. One of the keys on that is it has to be another whole number. Okay? We're not doing anything with fractions or decimals on those. Your common factors. The common factors are the sets of numbers that are the factor of every number in the set. In other words, I give you two or more numbers and say, okay, what factor do all of these have in common? In other words, what number is the factor of both of these numbers? The common multiples, when I take a set of numbers, again, I'll give you two or more numbers to start with, and say, what is a common multiple? In other words, when I multiply those numbers out, my whole numbers, where do they meet? And then multiply them out. And then your greatest common factor, I'll do this entire list, this is probably the most important one and one we're working on most today, is the greatest number is a factor of all the numbers in the set. So far we've been doing just two numbers at a time. You can do more than two numbers, and we'll show you a way to do that as we go through today's class. Why are someone with that marking in our text? Oh. Okay, right in front of me. Okay, we're gonna pause for just a second to make sure you guys have all of this. And then we'll go back into the module to see our. So that's actually it for that page for right now. Set that aside and let's go back into the book. And we go to page 16. And I take a whole lot of time on page 16 because we're going to show you another way to do this. It's going to be far more efficient than the way they're setting it up. But one way you can determine common factors is to use prime factorization. Start by writing in the product of its numbers. So then you can write the number, you can make this whole big table to write out the number and write out all the factors for each. And then you can find your common factors. In this case, we have a common factor at 2, we have a common factor at 7. And then if I have two numbers in there or more numbers in there, I can multiply them to get an inter common factor. In this case would be 14. Okay? But that's quite a bit of work to get all that done. You have to write it out. You have to build a table. You have to fill in the table. You got to list out all of the factors that are together. You got to realize which factors I can put together to find a common factor, or we can use a method that we call the cake. Did we start talking about this one last lesson with you guys? Okay. So we're about to show you something that is pretty awesome because it's going to combine our greatest common factor and least common multiple into one very easy to learn step. It's all focused though on your 4 key numbers. So remember our 4 key numbers. Already written in this, looked in there once. Wow, this is okay. We got my whole hands up. 2, 3, 5. Remember those. We write them down. Guys, most of what we do this entire year honestly comes down to those 4 numbers. So you have got to get them down. Why? Because what we're about to teach you is a method called the cake. So I take 56 and 42. I basically make them a big division bar. And I say, can we divide both 56 and 42 by 2? Yeah, if you say yes, then I do it. Okay? So I'm going to put a 2 on the side, and then I actually do the math. So 2 goes into 5 2 times, with 1 left over. It goes into 16, because 1 left over 5 8 times. 2 goes into 4 twice, goes into 2 once. So for those not following, what I just did, long division in my head. I said 2 goes into 5 twice. So I subtracted 4 and I had 1 left over, right? Then I brought down the 6, 2 went into 16 8 times. Subtract 16, got 0. So that's where that number came from, if you didn't see. Does that make sense for everybody? Okay. Now I check again, 28 and 21. And I divide both of them by 2. I can divide 21 evenly by 2? No. I divide them both by 3. I divide both 2 plus 8. 10. Can I divide 10 by 3? I can't divide 28 by 3. Okay, can I divide them both by 5? Both by 7. Once I get to a yes, now I'll do another layer. Well, I said yes, I can divide both by 7. That gives me a 4 and a 3. Well, 3 is one of my 4 key numbers. 3 doesn't go into 4, so I know that I'm done. So I've now found the greatest common factor because I'm going to multiply everything on the left. So here is your note you need to write. GCF is on the left. LCM is all of them. So in one easy step, we're now able to find both the greatest common factor and the least common multiple of a set of numbers. For my DCF, greatest common factor, I multiply 2 times 7 and I get 2 times 7 and I get 14. Waiting for people who are alive here. Okay? And then now I can use computer property multiplication. I can put these numbers together. But LCM is all of them. So I need to multiply all of these numbers together. So I'm going to try to do it a little bit easier. What? 3 times 4? 12. 12 times 7. 12 times 7, 84. 84 times 2 is 8, 168. So my LCM is 168. Because upon being asked for it, all the information is there to find it. So it's actually relatively easy to do. Does that make sense? So you do have options though. Now I want to make sure I point this out. You can do a factor tree, find all the prime factors for both of the numbers. You can then list them out in a table. You can make sure which ones they both have and realize that if they have more than one that are in common, you need to multiply all of those together in order to find the LCM. Or you can use the cake and just multiply the numbers on the left. Your choice. I highly recommend that you do the cake because it's way easier, guys. It literally comes down to adding math skills with 4 numbers, 2, 3, 5, and 7. Like you did? Okay, questions on what we just did? Yeah. I'll follow the video for 6 seconds. Make sure you get all that notes, especially this part, guys. This is really critical, and you will notice we actually have posters. Mine's there. You got the poster? I guess we can made and eventually put it back up. Okay, so we have notes on the walls for you as well to help you out and make sure you understand that concept. Yeah, I think I talked long enough. We're going to go ahead and go to the next page. So we're going to do, we'll do one more together. So I want you guys to be able to see this a couple of times before I let you up on your own. So again, you can do all of this. I can create a table of prime factors for each of the 2 numbers. I can identify all the common factors, both of them, and then I can figure out which one is the largest. Or I can say 54, 84. Can I divide them both by 2? Yeah, it'll be 27 and 42. I'll give you to do the math on those and see how we do it. Okay, 2 goes in 5 twice. That's 4 with what? With 1 left over. That puts the 2 up. Goes into 14. Another time. 2 goes into 8. 4 times. 2 goes into 4. 2 times. There wasn't anything left over, so I didn't have to worry about change. Or if you really have to, you can long division over here, so it's 4 divided by 2. Goes twice. You can have 4, 7. That's, again, part of the advantage, guys, of 2 by 7. We're doing numbers you should be able to do mentally in your head. And at the most, you're carrying over 1 or 2 numbers. Okay, then I check again. I divide 27 and 42. Oh, sorry about that. 27 and 42 by 2. Now I go by 3. So remember, the trick is figure out if it's doing 2 by 3. I add the digits. What's 2 plus 7? 9. 9 by 3. What's 4 plus 2? 6. I divide 6 by 3. So I know I can divide them both by 3. So I've now answered that question. Yes, I can divide them by 3. Now I just need to do the math to do it. 3 times 1 is 27. 9. 3 goes into 4 once with 1 left over. Goes into 12 4 times. So again, what I did mentally there, 42 divided by 3, 3 went into 4 once. Subtract 3, I gave it 1 left over. Goes into 12 4 times. Hope you guys will get to the point where you're doing that mentally. And I'll be quite as fast as I am, but you should still be able to get there. So now I check again. I have another layer. 9 and 14. I divide both of them by 2. By 3. By 5. By 7. If I've said no all 4 times, I'm done. So I'm now at the point where I can find my GCF and LCM. For my GCF, again, I just multiply the numbers that are on the left. So 2 times 3 is 6. For LCM, I multiply all of them. So this one gets a little more interesting. 6 times 9 is 54. 54 times 14. So I'm going to have to do this one. It's going to be 16, 21. So in the 10th place, I have to put a 0 to hold it. 1 times 54 is 54. Then I just add them up. Well, my LCM is 756. Even though the problem didn't ask for LCM, is it really difficult to find? Not if you got all the numbers there. DJ just put it together. It's a piece of cake. And the cake method. So good. Okay. Now that we've shown you that, we're going to ask you to find the GCF of these 2 sets of numbers. Once you've done that, we're going to show you how the cake is really cool, because not only will it show you the GCF, it will also show you how to set it up for a distributed property to figure it out. Okay? So, practice using the cake. Try to do sets A and B, and then we'll go over this. We'll give you guys about 4 minutes. So, you have to find the LCM cake, okay, if you want to. But right now, we just need you to find the GCF on this.
Okay, the directions say rewrite each sum. What is a sum? The answer to an addition problem using the GCF and the distributed property. So the first thing we need to know is the GCF of both numbers. Yes? Yes. And yes, we did it on the page before, but some of you are still confused, so we're going to do it again. I write my 2 numbers and I put my division bar. Can both of those be divided by 2? Yes. Yes, they're both even. 2 goes into 5. How many times? 2. That's 4. Leaves 1. Bring down my 6. 2 into 16? 8. That's 16. So it goes 28 times. 2 goes into 42. How many times? 2 goes into 4 2 times, and 2 goes into 2 1 time. Can 2 go into both of those numbers? No, because 21 is not even. Can 3 go into both of those numbers? No. Can 5 go into both of those numbers? No. Can 7 go into both of those numbers? 7 goes into 28. How many times? 4. And into 21, how many times? All right, what do we know about GCF? We know GCF is on the left, so I am multiplying 2 and 7. My GCF is 14. All right, but that's not all of the directions. It says rewrite these sums using the GCF. So I am multiplying 14 times what to give me the same answer as 56 plus 42? Guys, it's only the numbers on top. 4 plus 3. 14 times 4 is 56. 14 times 3 is 42. It gives us the same answer. Make sense? GCF goes outside the parentheses and the numbers on top go inside. All right, 54 and 84. Can both of those be divided by 2? 2 goes into 54. How many times? Let's see. 2 goes into 5? 2 times. That's 4. Leaves 1. Bring down my 4. 2 and 14. That's 14. Leaves 0. So 27. 2 goes into 8. How many times? 4. 2 goes into 4. How many times? 2. So that's 42. Can both of those be divided by 2? No, the 27 is not even. Can they be divided by 3? Yes. 3 goes into 27 how many times? 9. Now we need to do 3 into 42. 3 goes into 4 how many times? That's 3, leaves 1, bring down my 2. 3 into 12. So this is 14. Can both of those be divided by 2? 3, 5, 7. Then we're done. What do we know about GCF? It's always on the left. So my GCF is 6. That goes outside the parentheses. What goes inside the parentheses? 9 and 14, the numbers on top. So if I multiply 6 times 9, what do I get? 54. And 6 times 14? 84. It gives us our original problem. Does that make sense? Good. Turn the page.
Oh, wait, hold on.
Never mind. Relatively prime.
We do have a math term on here that we didn't put in the other packet that we gave you. What? Wow. Okay, so pull out your highlighters or markers or marking pencils. The term is relatively prime. So most of the time you're going to find a common number between them. That's why our circle go in. But if I go through my 2, 3, 5, and 7 and I say those 4 times, I don't have anything in common. That means that the greatest common factor is 1. So if they are relatively prime, the only common factor they share is 1. Dang it. I don't know why it says when I do all of it. Okay, so if my greatest common factor is 1, we call those numbers relatively prime. And that's the side note. If the numbers are relatively prime, to find the LCM, I just multiply the 2 numbers. And the first time they'll ever meet as multiples is once I have multiplied them by each other. Okay, we're going to go back into your packets real quick. Okay. So now we're on the front of the handout that we gave you. We're back to the front page. So in order to do our definitions, we're actually looking at a couple examples first. That should help you understand the definition. So when I use the number 16, to find the multiples of 16, what do I need to do? Right? What would be the multiples of 16? Maybe that'd be a better way to ask. What would be the next number? No? No? You gotta look at the factors. I need multiples. Right? 32. That should help everybody. So what would my next multiple be? 30? No? Got one in between. 48. No, Jordan. 62 or 64. Then 80. Then 96. So to find the multiples, what were we doing? Repeated addition. So I'm multiplying the base number 16 by a whole number. So this is times 2, times 3, times 4, times 5, times 6. Will my multiples ever end? No, because I can keep multiplying my numbers, right? So there are an infinite number of multiples. It's infinitely many. It will go on forever. However, on the other side, we have the factors. There were several of you that were trying to give me the factors. Let's try that one now. What are some of the factors of 16? All right, good. 4 and 4. So I need the factor pairs, guys. Give me a good. Good, 2 and 8. And the third factor pair. 1 and 16. I always like to start with the lower number. Okay? So our factors come in pairs because it's the numbers that I need to multiply in order to get to the number. Okay? So we talk about factors, there are a limited number, right? It's based on whether it's prime or composite. But even if it's composite, there's still a small limit because it's got to be all whole numbers to be able to find it. Yes. I know. I was questioning that on Miss McCann's worksheet as well. But she does do a really good job because she likes to give answers instead of just helping. I do want to add this note on the side. Numbers only count as factors or multiples when you multiply or divide by integers. What does that mean? Okay. A whole number. Okay? Not fractions or decimals. Okay? So whenever we're talking about multiples or factors, we're talking about whole numbers, not fractions and decimals. Okay? Kind of limits down what you can do. So that being said, now we want you to try it. So we've got 3 different things. Technically 4, because the first one has 2 parts. I need to list all the factors and the first 4 multiples of 72. So I'm doing factors, the first 4 multiples for this. Here I'm doing the factors of 45, and then 5 multiples of 8. So we've got 4 problems to do with you guys, about 6 minutes, 5 minutes. So we get started? Let's go ahead and look through our list. So first I wanted the factors of 72. So my factors, best to me, I like to break down into factor pairs. I always just start at 1 and start going up. So 1 times 1 is 72. 1 is 72. Can I go 2 to 72?
Yes.
Yes. So 2 and 36. Can I do 3 to 72? Yes. 7 plus 2 is 9, right? Can I divide 9 by 3? That means I can divide it by 3. I just got to figure out the other number. So 3 goes into 7 twice. And then it goes into 12 4 times. So 3 and 24. Can I divide it by 4? Well, we'll just do that math real quick. 4 goes into 7 once, with 3 left over. Will 4 go into 32? 8. So yes, 4 and 18. Can I do it with 5? No, 6. Do it again. 6 goes into 7 once, 4 left over goes into 12 twice. So 6 and 12. Can I do 7? 8. Yes, 8 times 9. Now that I got numbers next to each other, I know I'm done because all I would do is go the other way. So you're going to either take that list and rearrange it from smallest to biggest, or for me, you now list all the factors and throw it after you and say you do it in order, so you would be good on that. If we ended up with 1, 2, 3, 4, we end up with 6 factor pairs. Right? Yes, don't tap your feet. Okay, so now list our first 4 multiples of 72. Our first multiple is always the number itself, right? So you do it times 1. So 72, then what? Times 2 would give me 144. Then I can do times 3 or just add those 2 together and I get 216. Then I add 72 to 216 and I get 288. Pretty easy, right? Okay, now I need to list the factors of 45. So we start with 1. So I know 1 goes in every number. So it's 1 and 45. Can I divide it by 2? By 3? That's 4 plus 5. 9. 9 I can divide by 3, so I know I can. But I got to figure out the other number. 3 goes into 4 once. 1 left over. 15 goes 5 times. Can I divide by 4? No, by 5. Yep, 5 and 9. By 6. No, by 7. By 8. 9 and 9, so I know I've already got it. So I got factors going the other way. That's all your factors. Our first 5 multiples of 8. Again, we always start at the number. So 8, what's next? The next, 24, 32, 40. Now, getting the difference between factors and multiples. Good. Okay, turn our page over in your packet. So we're going to do the LCM of 9 and 12. Again, we'll set it up with the case. Remember, when I start with my numbers, write your numbers low enough to give yourself room to work up. I have to have room to work above my cake. Can I divide both of those by 2? By 3? Yes. Gives me a 3, so 9 divided by 3 is 3, 12 divided by 3 is 4. Well, I have 3 and 4. Is 4 one of my key numbers? No, but 3 is, doesn't go into 4, so I'm done. So we actually already found our GCF. What's our GCF? 3. My LCM is all of them, so we multiply everything. 3 times 3 is 9 times 4 is
36.
LCM is 36. And you know, didn't ask it, my GCF is 3. If you do the cake, it's very easy to find those. Everybody seeing it? Okay. Those of you not seeing it, we've got a few more for you to do. I am going to show one other one because we haven't done 3 numbers yet. Because there's a little trick when you're doing LCM with 3 numbers. GCF is the same though. But all I'm going to do is now I've got 3 numbers. So I'm going to put 3 numbers under my division bar. 9, 15, 18. Now I'm looking for what I can divide all 3 of them by. Can I divide all 3 of them by 2? No, by 3. Yeah, so I do it. So I put the 3 here. So I can go 3 here. I can go 5 here. I can go 6 here. And I check for all 3. Can I divide all 3 of them by 2? By 3? Okay, so I've already said no. I'm past 3, so I know I can't go any further. So here's where it's a little different between GCF and LCM. I've now found my GCF, it's 3. But now I need to build what I call a glass ceiling. So my GCF is 3. But for LCM, now I need to see if there's any 2 numbers that have a common factor. So are there any 2 numbers here that I can divide by 2?
Yes.
What?
5 and 6.
I can't divide 5 by 2.
2.
There's no 2, it's a 3.
And
Guys, we have 3, a 5, and a 6. Can I divide 2 of them by 2?
no.
No. Go through your list. Can I divide 2 of them by 3?
Yes.
I think this is where you're all confused. You saw the 3 that we were at 2. Go through your list to make sure you don't miss anything. So now that I found my GCF, I'm finding the LCM. I said, okay, well, there's 2 of them that have a 3. So if I can still divide it, I do. 3 divided by 3 gives me a 1. If I can't divide it, I just bring that number up. So I bring up a 5. Then the 6 divided by 3 gives me a 2. Okay? I'm now at 1, 5, and 2. 1 and 2. 1's neither flying or deposit. 2 is my first prime. 5, so I can't go any further with that. So I'm now ready to find my LCM. Just as in the cake with 2, I'm still multiplying everything on the outside. One really cool thing about this, I can use commutative properties. I can do the math in any order I want. So I look at the numbers and I say, what's going to be easy? I always love multiplying by powers of 10, so I have 5 times 2 on top. That is 10. 10 times 1 is 10. 3 times 3 is 9. 9 times 10 is,
90.
so my LCM is 90. Guys, literally the only hard thing about this is the glass ceiling in 3 or more numbers. I have to pull out common factors of 2. Other than that, it's exactly the same. Yeah. I will. Okay, so now you guys have 6 minutes. Find the GCF of these 2 numbers, LCM of these 3, and GCF of these. If you want a bonus, you can find GCF and LCM for all 3 sets of numbers. So you've got 3 sets. We'll give you guys 6 minutes. Go. Okay, guys, let's go through this really quickly. Again, one of the big keys on this, I need to write low enough to give myself room to write above. So a lot of you with big handwriting that we're starting like here, you're not even close to having enough room. Okay, start low. 40 and 64. Can I divide them both by 2? Yes, so I do it. Gives me 20 and 32. Can I divide those by 2? Yes, so I do it. 2 gives me 10 and 16. Can I divide those by 2? Yes, so I do it. Gives me 5 and 8. Can I divide those by 2? 3, 5. And 5 is already my number, so I know I'm done. Remember, my GCF is on the left. For GCF, I'm multiplying all 3 of them. 2 times 2 is, 4 times 2 is, so my GCF equals 8. We didn't ask for LCM, but can I find the LCM? Yeah, really easy. Because again, I get computer property and do it in the order I want. Well, I already see it 2 times 5, that's 10. That makes it 2 times 2 is 4. 4 times 8 is 32. 32 times 10 is 320. Once you've set it up, it should be really easy for you. Okay? Now, the 3 numbers is a little trickier. I'll give you that up front. But if you just follow the process, it isn't hard. We go 7, 9, 21. Can I divide all 3 of them by 2? By 3. By 5. By 7. Okay, so we just gave you that term. That means that they are relatively prime. So my GCF is 1. So now is where my glass ceiling comes in because I now need to look for any 2 numbers I can divide. Are there any 2 numbers I can divide by 2? By 3. So now I'm going to add another layer. If I can't divide it, I do. If I can't, I just bring the number up. So 7 divided evenly by 3? No, so I bring it up. 9 divided by 3? 3. 21 divided by 3? 7. So now I have another layer. I'm checking again. Any two of them, I can divide by 2. By 3. 5. That's 7. I got 2 sevens. I can divide 7 by 7, can't I? Yeah. So I have one more layer with a 7. So that gives me a 1. 3 cancel comes up and a 1. Once I've got multiple 1s, I know what I got it. So my GCF, again, the reason I did the class ceiling, my GCF was 1. It was the only factor that hit all 3 of them. So my LCM, I'm going to multiply everything. So the 3 1s, that's all this 1, right? So 3 times 3 is 9 times 7, 63. Okay? Our last set, we have 14 and 18. And 14 and 28, sorry. And I write both of them by 2. Yeah, so I do it. Gives me a 7 and a 14. And I both those by 2. No, by 3. 5, 7. Guys, you get the idea? If people work through this list, you should get to the point where you're going this quickly every time. So yes, I can do it by 7, gives me a 1 and a 2. Once I get to a 1, I know I'm done. So my GCF is just the 2 on the side, which is 14. Good, you multiply them, don't add them. Then after LCM, but I can do that because 14 times 2, which gives us a good indication. Here's the math fact. The smallest number that could be the factor of 2 sets is the smaller of the 2 numbers. Okay, it's 2 sets, or 14, 28, and 14. The smallest number that can be the least common multiple is the bigger of the 2. LCM is 28. So if the 2 are multiples of each other, they'll actually be their own LCM and GCF. Apparently, we're going to page 21. Okay? So, we've only got 10 minutes? 9 minutes left? So, we want you, for as many of these, we got 3 sets of numbers for you. Find the GCF and LCM for as many of those 3 as you can. We will give you 3 minutes. I'll give you 1 minute to do it before we go home. I only have 1 minute, and can't touch you timing me, so this will be fast. 9, 15. Can't do 2, I can do 3. Gives me 3 and 5. 3, 5 are my key numbers. GCF is 3. LCM, 9 times 3 is 45. 9, 10. Can't do 2, 3, 5, or 7. That means they are relatively prime. 1. LCM is 90. 5, 9. Can't divide them both by 2, 3, 5, or 7. Means they are relatively prime. GCF is 1. LCM is the 2 multiplied together. 45. Did I make a minute? Guys, the point is not to say, wow, this board can do this really fast. The point is to say, once you understand the process of checking those 4 numbers, this becomes really easy. Because my LCM is left here on the left, my GCF is on the left, my LCM I'm just multiplying all of it. Remember, they are relatively prime. For my LCM, I just multiply the numbers. It's literally that easy. Okay, let's turn to our homework. Go to page 25. I have a special note on you for number 25 for your journal entry. Because a lot of students read this, think all you have to do is underline, circle one of those, but if you read it, it says, use complete sentences to explain your choice. If you haven't explained your choice, did you do the journal entry? No. There are some very important instructions we're about to go through for doing your homework. Number 1, you must create a factor tree and prime factorization for each number. Gone through that. Again, go through the list, 2, 3, 5, 7, it makes it easy. If you start with any factor tree, just make sure you do it. If you want to use factorization, use factorial notation, you may. Number 2, you have 2 options. You can do part A, list all the factors, what factors they have in common, and what is the greatest common factor. Or you can use take to find GCF and LCM. Yes. So you do all four of those, or you can just take and just give me GCF, LCM. Those directions follow over. Oh, sorry, it's down below. Same thing here. You can do all of these different pieces, or use K to find GCF and LCM. So if you do it, if you use K, you have to add the LCM, not just GCF. But I can assure you, it'll be a lot faster if you do it, because it's easier to do those. And this one, here's your other last one. Determine the least common multiple. So find the K and at least one other common multiple. Once you have found a common one, I'll give you it. Multiply by 2 or multiply by 10. Once you have found a common multiple, any multiple of that number will also be a common multiple. Great question. Right now, so I need to do the stretch. Of all of the exercises you do almost all year, honestly, this is the one I would most highly recommend doing, because we haven't had a ton of practice on this, and practice is really necessary to get comfortable with this. If I were you, I would do the stretch, and I would actually find both the LCM and GCF for each set. Yeah, 210 that page out, guys. Question. One at a time. Good luck, guys.